Hi, sixth graders. Today we're going to talk about the area of regular polygons. Okay, the area of regular polygons. You're actually not going to need any graph paper today, and we're not going to learn any new formulas. We're going to use formulas you already know to find the area of regular polygons. So first of all, what is a regular polygon? Well, let's look. First, we're going to look at the five-sided polygon, which is the pentagon. Okay, both of these are examples of a pentagon. However, this one is the regular pentagon because all of its sides are the same length, and this one does not have all of its sides the same length, so it is not regular. So regular means all of its sides are the same length. Here is your regular pentagon. Okay, let's look at the hexagon. Okay, the hexagon, of course, is the six-sided shape. So both of these are an example of a hexagon, and the easiest way to remember how many sides a hexagon has is that hexagon has an X in it, six has an X in it, six-sided shape. So again, these are both examples of hexagon, but this is a regular hexagon because all of its sides are the same length. And then we're going to look at the octagon. Okay, the octagon is the eight-sided shape. Here is an example of an irregular octagon. So 8 sides, but they're definitely not all the same length. Then the regular octagon is a very recognizable symbol. So the stop sign is a regular octagon. So again, the 8-sided shape and all of its sides are the same length. Okay? So we're going to look at those three. Obviously, there are more regular polygons than those three, but we're going to focus on the pentagon, the five-sided shape, the hexagon, the six-sided shape, and the octagon, the eight-sided shape. Okay, so let me grab those three shapes so that we can work with them. Okay, so let's grab the regular pentagon, the regular hexagon, and the regular octagon. We will use all of these today as we are working some problems. Okay, so let's look at how we can use what we know already, what formulas we know already to find the area of regular polygons. Okay, so let's look at this regular pentagon. Okay, so when you have a regular polygon, you can do this with it. So I'm going to put a dot about where the center of this regular pentagon is. Okay, and it's not going to be perfect. And I'm going to go out to every time it bends or its vertices. Okay, and I'm going to split it into triangles. And obviously, like I said, it's not perfect, but it will be split into identical triangles. And notice that the five-sided shape, or the regular pentagon, is split into 5 triangles. So whatever the regular polygon is, if you split it into triangles, it will have the same amount of triangles as it does sides. So the five-sided shape can be split into 5 identical triangles. Here is our six-sided shape. So how many triangles do you think it can be split into? You guessed it, 6. And then here is our 8-sided shape. Again, we would be able to split it into 8 identical triangles. Okay, so let's see, what does that help us? How does that help us find the area of these regular polygons? Well, we're going to look. So let's look at this example right here. Okay, here we have a pentagon, which we know is the five-sided shape. Okay, you see here that the sides are all 16. And then over here, it's showing, okay, we already know that it can be split into 5 identical triangles. Then we're told in the problem that the sides of it are 16. It only has to write that once. Here it's just showing you that they're all 16. You really only need to put it here because then you already know if it's regular that all of these are going to be 16 as well. But then it also tells you that the height of this triangle is 11 centimeters. Okay, so we know that the base of this triangle right here is 16, and we know the height is 11. Okay, well, you know the area formula for triangles. Remember, its area equals half base times height. So what would be the fastest way to get the area of a triangle that has a base of 16 and a height of 11? Okay, hopefully you thought that the fastest thing to do would probably be to take half of 16, which is 8, and multiply that times 11, okay? Which would tell us that that one little triangle right there has an area of 88 centimeters squared, okay? Now, since we just said that this is the 5-sided shape that is split into 5 identical triangles, okay? We know that this is 88 centimeters squared, and we know that we have 5 of that exact same thing. So let's take 88 and let's multiply that by 5. That should be the area of this regular pentagon. So I'm going to give you a minute to do that, and let's see what we get. So again, 88 for this, and we have 5 of the same thing. Okay, hopefully you got 440 centimeters squared. 440 centimeters squared. Again, 88 times 5, 440 centimeters squared. Okay, let's try another problem that is similar. Okay, let's try this one. Okay, this time we're going to have the hexagon, the 6-sided shape. And again, it's just telling you here that all of the sides are 9.3 inches. And then over here, it's just written once because again, what if we know that that's 9.3, then so are all of the rest, okay? So what do you think we're going to do to find the area of this entire regular hexagon if we know that the base of this triangle is 9.3 inches and the height, we're told that the height is 8 inches? Okay, hopefully you thought, well, we're going to find the area of this one triangle and we have 6 of the same thing, okay? So let's look at these two numbers. What would be the fastest way to find the area of that triangle right there? What would be the fastest way if we have a 9.3 and an 8? Okay, hopefully you thought that, well, the fastest thing to do would be to half that, make it a 4, and multiply that by 9.3. Okay, so 4 times 9.3. So I'll give you a minute and see what you get. So 4 times 9.3. Okay, hopefully you got 37.2. Okay, 37.2 inches squared. And then again, we have 6 of the same exact triangle. Okay, 6 of the same thing. So we would take 37.2 and we would multiply that by 6. Okay, 37.2 for this one little triangle, and we want to multiply that by 6 to find the area of this entire thing. So I'll give you a minute to see what you get for that. Okay. All right, hopefully you got 223.2 inches squared, okay, for the area of this entire thing. Okay, let's try another one where you're going to kind of be given the information and then we're going to put it on the shape based on what we're told. Okay, let me erase this. Okay. All right, so we are told that Blake drew a regular pentagon with sides that were 6 inches. So that means we're looking at this shape right here, okay? And it tells us that the sides are 6 inches. So again, we just need to write that once because that means that all of them would be 6 inches, okay? Because it's a regular pentagon. The sides are 6 inches, and then he divided it into 5 identical triangles. So again, since it is the 5-sided shape, we already know that it can be split into 5 identical triangles. Okay? Next thing we're told is that he measured the height of one of the triangles to be 4.1 inches. Okay, so he measured the height of one of them to be 4.1 inches. Okay, we've done a couple of these now. So again, we know that first we need to find what would be the fastest way to find the area of that little triangle there. Well, the fastest thing would be to take half of 6, which is 3, and multiply that by 4.1. So let's do that first and see what we get. So 3 times 4.1. Okay, hopefully you got 12.3. 12.3. And again, since this is a pentagon, without even splitting it, we already know that it's going to be able to be split into 5 identical triangles. So let's take that answer and then multiply it by 5. So 12.3 times 5 would give us the area of this regular pentagon. So let's see what we get. Okay, hopefully you got 61.5. 61.5 inches squared. 61.5 inches squared. Okay, let's try another one. Okay, this one is going to be a little bit different. We're going to be given some different information. So let's erase this. And we are going to be looking at the hexagon. Okay, so the 6-sided shape. Okay, so we're going to be looking at this shape up here. Okay, in this problem, we have a hexagon. And again, we already know because it is has 6 sides, that it is going to be able to be split into 6 identical triangles. Okay, 6 identical triangles. Okay, well, this time we are actually told that the area of the entire hexagon is 372 inches squared. Okay, so we're told the area of the entire thing. All right. So what do you think we would do to find the area of each individual triangle there if we know that the entire area is 372? Okay, 6 identical triangles with an area of 372 inches squared total. Okay, what do you think we would do? Well, since there are 6 identical, you would divide 372 by 6. Okay, 372 by 6 is going to tell us the area of each individual triangle. So first of all, let's see what that would be. So 6 into 372, let's see what the area of each little triangle would be. Okay, hopefully you got 62. Okay, 62 for each of the little triangles here. And then we're also told in this problem that the height, okay, the height of one of the triangles, which would obviously be the height of all of the triangles, is 4 inches. Okay? Well, what we want to know is what is this right here? Okay, what is this right here? Or in this problem, that would be the base of that little triangle right there. And we did a couple of these problems when we were doing triangles. And so again, we know that area equals half base times height. And so we're going to take our area, which is 62, and we're going to put it in here. Okay, the half is going to stay half. The base we don't know, but we do know that the height is 4. Okay, then we are going to do just like we did when we were learning about triangles. We can do half of 4, which is 2. So we're going to have 2b left on this side, and we're going to have 62 on this side. So again, we have an equation, and we know that if we're multiplying by 2 here, we're going to take it over to the other side and divide, and so we're going to get b equals 31. So the missing base is 31, or it's the same thing as what are the sides of this hexagon? Well, they're all 31, if that is 31, okay, 31 inches. Okay, let's look at a couple of other things. All right, so what if we have an octagon, a regular octagon, which is right here, and it can be split into 8 identical triangles, but we are actually going to split this a different way and find the area of it, splitting it into a couple of other shapes that we know. So we're going to take this regular octagon and we are going to do this to it. We're going to go from here to here, and we're going to go from here to here. So we're just kind of cutting it apart, okay? So we have a trapezoid, a rectangle, and a trapezoid, okay? So we know that the rectangle is a type of parallelogram, and obviously these are trapezoids. So we're going to use trapezoid formula, and the parallelogram formula to find the middle, okay? So let me tell you the information about this. So first of all, I'm going to tell you that this is 4 inches, okay? 4 inches. And again, because that's 4, you don't need to write it every time, okay? We know that all of the sides are going to be 4 inches if one of the sides is 4 inches, okay? So 4 inches. Then we're going to be told from here to here, okay, from here to here, that distance is 12 inches. Okay, from here to here is 12 inches. And then we're also going to be told the height right here, 3 inches. Okay, now we have everything we need to find the area of this regular octagon. So let's see what we would do. So first of all, we need to remember our parallelogram formula and our trapezoid formula. So first of all, remember the trapezoid formula is area equals half the height times the addition of the 2 bases, okay? So let's look at this trapezoid up here, okay? So we have our base here, and our base here, and our height here. And so let's fill in our formula. So we're going to have area equals half. Okay, we know the height. Okay, the height is 3. And then we need to add the 2 bases together. So we have, again, we're told from here to here is 12 inches. So that means that this is 12 inches right here. And again, because all of the sides are 4, we know that that is 4 right there. Okay, so we have 12 here. And we have 4 here. So we need to add those 2 together, which would be 16. Okay, so half times 3 times 16 is going to be the area of our trapezoid. Okay, so just like with the triangles, we think about what would be the fastest way to get the answer. Well, the fastest thing to do would say half of 16, which is 8. Take 8 and multiply that by 3, and we're going to get 24. So 24 inches squared would be the area of this trapezoid, and obviously this trapezoid and this trapezoid are the same, so that means that we have 24 for the top and we have 24 for the bottom. Okay, the middle shape is a parallelogram, is a rectangle, which is the type of parallelogram, and so we know that that formula is area equals base times height. Okay, area equals base times height. We know that the base is 12, and the height, again, because all of its sides are 4 inches, the height is 4. So we're going to have 12 and 4, so we just multiply those 2 things together, base and height, 12 times 4, which is going to be 48. Okay, then all we do is add everything together. So the top trapezoid is 24, the middle parallelogram is 48, and the bottom trapezoid is also 24. So we're just going to add these 3 things together. So I'll give you a minute to do that. So 24, 48, and 24. Okay, hopefully you got 96 inches squared. 96 inches squared. All right, let's look at something else. Again, even though each of these can be split into identical triangles, sometimes you might see them split into some other things. And so let's look up here at this regular hexagon, and we're gonna look at something that you might see with a regular hexagon. Okay, so we're gonna take this regular hexagon and we are going to split it like this. I'll put a dot here. We're gonna go this way and this way and this way. Okay, so I have split this regular hexagon into 3 identical rhombuses. Okay, 3 identical rhombuses. Again, a rhombus is a type of parallelogram. So we know that we can use the parallelogram formula to find the area of this regular hexagon using this information. Okay, so we have a regular hexagon, and we're told that this is 8 inches, so all of its sides are 8 inches, and then we're told that the height inside here, okay, that is 6 inches. Okay, 6 inches. So, again, the area formula for a parallelogram is area equals base times height. So we're gonna have 8 times 6, and that's gonna be the area of that one little rhombus. So again, 8 times 6, hopefully everybody knows that from memory, 48 inches squared. And we have 3 of the same thing, okay? So that means we would take 48 and multiply that by 3. So I'm gonna give you a minute to figure that out. So 48 times 3, and hopefully you got 144 inches squared. 144 inches squared. All right, let's look at one more thing. Let's look at this problem. Okay, we have an octagon. Okay, we already know that the octagon, the regular octagon, can be split into 8 identical triangles. So we see here it's split into 8 identical triangles. Okay, well, on this problem, only half of one of the triangles is shaded. Okay, half of one of the triangles is shaded. So if we have 8 whole triangles, okay, how many of these would we have then in this entire regular octagon? Well, we would have 16, because 1, 2, and then 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we're gonna have 16 of those, of that shaded part. Okay, it tells us in this problem, the shaded area is 9.7 square inches. So it's telling us that this right here is 9.7 square inches. Okay, and we want to know the area of this entire octagon. So again, this is 9.7. We just said that there were 16 of these. So we're going to take 9.7, multiply it by 16. So I'll give you a minute to see what that would be. So 16 times 9.7. Okay, 155.2 hopefully is what you got. 155.2 inches squared. They call it square inches, same thing, for the area of this regular octagon. Okay, well, that is everything you need to know about finding the area of regular polygons. Basically, you take information you already know and apply it if it can be split into triangles, or if it can be split into other shapes that you know, like for instance, a minute ago when we split the regular octagon into trapezoid, parallelogram, and trapezoid. Okay, either way, you have formulas to help you find the area of the regular polygons. So I will see you next time.